Alright, so we are going to pick up on determining sample size for when you're estimating the mean of the population. So we went over proportion last week, and then your instructor went over confidence intervals for the mean this week. Now, so the most important thing to remember when you're going into this last portion of the class and the final is you need to recognize the difference between a proportion or a mean. Proportion represents a categorical variable that's being summarized. So maybe I want to calculate the proportion of students that voted in the election. And so voting in the election is a categorical yes or no variable, and we summarize that using proportion. Or maybe I want to estimate the mean GPA of students. GPA is a measurement and it's a quantitative variable. So to calculate that, I would get an average. So that's the difference, and it's really important that you recognize that and get some practice with that. Alright, so we're going to start going over a sample size. So just like we did for proportion, we're going to go over a sample size when we're estimating the population mean. So we would want to calculate the sample size if we are interested to see how many people we need to survey. Sometimes it's really costly to survey people, so we don't want to survey too many, but we don't want to survey too few because we won't get very accurate results. Okay, so here's the formula for sample size. And to calculate the sample size, we need to know the critical value, which is z. That represents usually a 90%, 95%, or a 99%. And we need to know the population standard deviation, which is sigma. And we need to know the margin of error, which we represent as e. And so we just take that quantity and square it. And so these things are given to you in the problem. And then we always remember to round up to the nearest integer. And because it wouldn't be too bad to survey one extra person, so that's why we would round up instead of round down. Alright, so let's use that formula for 7.3.33 in the book. So there's an IQ test designed so that the mean is 100 and standard deviation is 15. Find the sample size necessary to estimate the mean IQ score for statistics students. We want to be 95% confident, so that's our confidence level. That's how we would get our z-score. That the sample mean is within 2 IQ points, and so that would be the margin of error. We want to be within plus or minus 2 points. And then sigma is 15. So I have all the ingredients to use this formula. I have z, because I know that it's 1.96 for 95%. Sigma and e are given to me. So I just want to calculate the sample size. So I take 1.96 times 15 divided by 2. And I would square that. And so that's equal to 216.09. And remember, we round up. And so I would just make that 217. And that would be the number of students that I would want to sample to get a 95% confident interval and be within 2 points of the true mean. Alright, so for the rest of the chapter, we're just going to do an example. And so we have the mean weight of all 20-year-old women is 128 pounds. So all 20-year-old women. A random sample of 40 vegetarians who are 20 years old showed a sample mean of 122. Assume sigma is equal to 15. So the first question says, is the number 128 a parameter or statistic? And so a parameter describes the whole population, and you can sometimes uses the word all or entire. And so 128 is describing all 20-year-old women, their weight. And so 128 is a parameter. And then it says, how about the number 122? Well, 122 came from a sample, so that would be a statistic. So 128 a parameter, 122 a statistic. Next thing we want to do is calculate the margin of error. And so if you go up a couple pages, you'll see the margin of error formula. That's right here. It's kind of like the sample size formula. Well, it is the sample size formula, just rearranged. So I need Z, and we're given 95%, so I know that, and then sigma and n are given in the problem. Alright, so I'm going to come down here and get the margin of error. Alright, so the margin of error is my value for Z, so for 95%, it's 1.96 times sigma, which is 15, divided by the square root of 40. And that's equal to 4.65. Alright, so that's my margin of error. Now I want to create a 95% confidence interval for the true mean weight of all vegetarians of that age. Alright, so my confidence interval is for the mean, and we always have a point estimate, so x bar is our point estimate. And we have plus or minus the margin of error. So let's go up and get our sample mean. This is a sample mean weight of 122. So we have x bar is equal to 122. So down here I just take 122 plus or minus the margin of error, and we just calculated the margin of error, so plus or minus 4.65. Alrighty, so this gives me an interval of 117.35 up to 126.65. And that's in pounds. Let's go ahead and do it on the calculator as well. So the calculator, I want to go to stat, and then I want to scroll to test. For a confidence interval for the mean, I want to go down to number 7, Z interval. And hit enter. And now most of the time we're going to be just given the summary statistics. If we're given the raw data, it's a little bit different, but you want to scroll over to stats, hit enter, then go down and I've already entered this stuff, but enter the standard deviation as 15, enter the sample mean as 122, the sample size as 40, and then the confidence interval as 95. And then you hit enter. And we get the exact same confidence interval using our calculator. Alright, so I'm going to close that, and I'm going to go ahead and interpret the confidence interval. So our population for the confidence interval is vegetarian women 20 years old. So I would say we are 95% confident that the average weight of all 20-year-old vegetarians is between 117.35 and 126.65 pounds. And that's it. I want to make sure I mention the confidence level. This is the confidence interval for the average, so I have the word average in there. And it's for the population, so I have all 20-year-old vegetarians, which is my population. And then the last question, does it appear that on average 20-year-old vegetarians weigh less than the general population for that age? And so we're given up here that the mean weight of all 20-year-old women is 128, but we're pretty sure that vegetarians on average weigh between 117 and 126. And so it does appear that they weigh less. And so the answer would be yes, since the confidence interval is below 128 pounds.